Welcome to part 2 of our discussion about energy. So in this lesson I want to talk to you about energy around us, energy in the environment, and then end with the design challenge, which is to reduce your carbon footprint. So let's begin with energy around us. It turns out that when you think about energy based on what we discussed in the first part of this video, the good news is that you can break up energy into two primary types. One is the energy that comes due to the motion of a body, known as kinetic energy, and the other that comes from the position of a body in a certain environment, and this is known as potential energy. So to give you a sense of what is kinetic and potential energy, a nice way is to think about a roller coaster ride. For those of you who have not been on a roller coaster ride, you will probably know that there are a series of peaks and valleys, and there is a rail that runs along these peaks and valleys, on which you have a train car in which you sit, and then you go up and down through these peaks and valleys. Now, for those of you who have been on a roller coaster ride, you will have noticed that when you get to the top of a peak, you are almost stationary or moving extremely slowly. And then as you go down, you gain speed, and then at the bottom of the hill, when you're in a valley, you're at your maximum speed, and then you start slowing down as you go back up again a hill. So what's happening here is that the kinetic energy and the potential energy are being constantly interchanged, because the potential energy comes from the height of the car from the ground, while the kinetic energy comes from the speed at which the car is moving. So here is a form of kinetic energy that comes from the mechanical motion of objects. It is half times the mass of the object times the square of the velocity. While here is the potential energy that comes from the height of the object above Earth. It's given as mass times the acceleration due to gravity g times h. So kinetic energy has 5 different forms. The mechanical form that we just referred to. It also appears as heat energy or thermal energy due to the vibration of atoms and molecules. It appears as electrical energy due to the motion of charged particles. It can appear as sound energy due to the motion of gas molecules or gas particles or air molecules. And finally, it can also appear as light or radiant energy due to the motion of light particles known as photons. On the other hand, potential energy can appear due to the position of an object above the Earth's surface at a certain height, due to the gravitational effect of Earth. This is known as the gravitational potential energy. It can appear due to the change in the spacing between atoms in an object, due to something called elastic potential energy. It occurs due to the bonding energy between atoms, and this is known as chemical potential energy. And finally, it can appear due to the forces inside the nuclei of an atom, and this is what is known as nuclear energy. So the good thing is that because of the fact that you can categorize all energy either in terms of kinetic or potential, it is also it also helps us understand from this roller coaster analogy that energy can transform between each other. So in other words, you can transform not only between kinetic to potential energy, but also between the different types of energy within kinetic or within potential energy. Okay, so that's something important to remember. The next thing to note is that energy is conserved, and what that means is that you cannot destroy the total energy of a system. You can only change it from one form to another, but you cannot create extra energy, and you cannot remove energy. You cannot decrease the total amount of energy. And so as an example, if you think about a cannonball being fired out of a cannon, it starts with lighting up a fuse that heats up a chemical that then explodes, and this propels the projectile out, and the projectile goes out with a high velocity, and then finally it reaches a fairly large height at which it has reached its maximum height, at which its velocity is the lowest, and then it starts coming back down and again the energy that it transformed from kinetic energy into potential energy is now regained back as kinetic energy, and finally it strikes the ground, where it creates it creates sound and heat, and that is now the final transfer of energy into from the initial chemical energy that you created. Now in all this, if you calculated the total energy at each point, you'll find that it is the same, and that's what conservation of energy means. So as a statement, the law of conservation of energy states that the total energy of an isolated system remains constant or unchanged over time. Now it's important not to confuse this statement with conserving energy, because conserving energy is basically the act of using energy wisely, right? So for example, instead of taking a car to go to the grocery, I decide to conserve the energy of gasoline by actually walking or cycling to the grocery store. So that's what conserving energy means. Now, because of the fact that energy is conserved, it also naturally lends into the fact that energy can be transferred between different forms, as we saw from the example of the roller coaster being transferred between the kinetic energy and the potential energy as the roller coaster moves through its peaks and valleys. Okay, now let's move on to understanding a bit about energy and the environment. So I'll begin with two examples here. One is a newspaper headline from about 7 years ago that talks about the fact that in South America, in the Andes, ice that had accumulated over 1600 years melted in time frame of 25 years. You know that ice melts because of warmer temperatures, and so what this says is that the temperature is much warmer than it was over the past 1600 years, and so the ice is melted very quickly. You can see a similar effect in Alaska in the 1920s, which is the image here. You had a lot of ice at this glacier known as the Pedersen Glacier, and now this is in 2005. You can see that most of the ice is melted. Okay, and what are these saying? These are saying that the actual temperature of the earth is increasing, and this is what is known as global warming. And if I actually plot out the average change in earth's temperature as a function of time, shown as years here along the x-axis, you'll see that the average temperature has actually gone up, and right now there is an increase of the average temperature, or there is an increase by 1 degree from what used to be the average temperature of the earth. Okay, so this it turns out a large fraction of this increase in temperature is due to man-made causes. So to understand that, we need to understand where our energy comes from. If you think about lighting a bulb at home, this bulb can be lit by two types of energies. The first one is the non-renewable energy. For example, you can burn coal, oil, gas, or get nuclear power that eventually transforms into electricity that comes to your home to light up this bulb. Alternately, you can be using renewable energy, such as by burning biomass, by water waves, by solar energy through solar panels, by hydroelectric power through dams, by geothermal power stations, or by wind energy. And these are known as renewable. So what's the difference between the two? Well, it turns out that renewable energy is one that is not limited in its availability in the lifetime of what one would call the Earth's lifetime, which is billions of years. On the other hand, non-renewable energy is something that will run out, and you cannot replenish this in the Earth's lifetime. Okay, so that's the way we think about renewable and non-renewable energy. Now it turns out that things like coal and oil and natural gas are non-renewable, and that means as we are using them up, there is no way they are getting refilled, and so at some point there's a danger of running out of them. Now, to think a little bit more in the context of how the electricity comes to your home, let's think about what is known as a power plant. In this case, I'm showing you a power plant in which coal is being used or fuel is being used to heat up water in a large boiler, and you heat it up so that you create steam, which is water vapor, and this steam is run at high pressure through a fan or a turbine that rotates at high speed. And when the shaft that is connected to this turbine is put into a set of electrical coils, that can lead to the generation of electric power. So this is the fundamental process by which you start from burning coal or gas or nuclear, or use nuclear power to heat up water and eventually run a turbine and generate electricity that comes to your home. Now, it turns out that if I look at the fraction of the different sources of energy that generate electric power for our homes, we find that coal and gas and oil make up almost 70% or close to 68% of 65% of the total amount of energy. Okay, and on the other hand, and by the way, if you add nuclear as well, that gets you closer to 75%. On the other hand, if you look at hydroelectric and solar, these contribute about 26% of the total amount of energy. So clearly we are using a lot of non-renewable energy to power our homes right now. Okay, and the other problem with using non-renewable energy is also, as I said, burning things like coal and oil and gas produces harmful toxins that are put into the atmosphere. Now, to understand the role of these toxins or these gases that are released by burning coal and natural gas, we have to understand something known as the greenhouse gas effect. So on the left side here is shown a figure in which during the daytime we have sunlight that heats up the earth, and then as the sun sets and we go into the nighttime, the earth re-radiates some of that heat back out into space by something known as infrared radiation. So this is a form of kinetic energy in terms of light, and so that infrared radiation is released back. Now, in our atmosphere that surrounds the earth, there are certain gases such as carbon dioxide and methane and nitrous oxide that actually trap this infrared radiation. Okay, so that means essentially some of that heat is trapped in our atmosphere here, and that results in keeping our earth at a certain temperature. Now, as man-made carbon dioxide and methane and nitrous oxide gases have increased, so these greenhouse gases have increased in content, the amount of heat being trapped by the Earth's atmosphere has gone up, and that is therefore leading to an increase in Earth's temperature. And this is what the greenhouse gas effect is. It is clearly evident from the amount of carbon dioxide that is present. You can measure the amount of carbon dioxide that is present in an Earth's atmosphere, and here is the data from measurements done by NASA. And what it shows is that in our current time, right now, here we have a carbon dioxide amount that is significantly higher than what has been recorded in the past. So we are close to about 400 parts per million of carbon dioxide. So this is about 400 ppm, and that means for every million gas molecules in air, 400 of those are carbon dioxide, and this is significantly higher than what has been seen in the past. So the bottom line is that we need to solve this problem very soon, otherwise our increase in Earth's temperature is going to be unrecoverable, and essentially it will melt all the ice and lead to significant changes in weather, and eventually leading to massive destruction. Okay. So the good news is that we can all do something, and we can do something right now. And so that's where we enter our design challenge, which I call reducing your carbon footprint. So if you look at the energy use inside your home, the first thing you can do is identify every gadget or machine that utilizes energy, especially energy that is being piped into your home through electricity or natural gas. and then that energy can be broken up into being either coming from renewable or non-renewable energy sources. For example, if you have a solar panel on your roof, then you are using renewable energy, and that is great. But if you are using a non-renewable energy source that is producing greenhouse gases like oil and gas and coal, then we need to be able to account for all of that. Now it turns out that by calculating the amount of energy that you're using in your home in kilowatt hours that come from non-renewable energy, you can translate that into a volume of carbon dioxide that is effectively being released by the power plant through this calculator here that you can find at the EPA, which will be available in the link with this file. And so for each gallon of gas, for example, if you use 1 kilowatt hour of energy from a natural gas plant, you are putting 1.2 pounds of carbon dioxide into the atmosphere. This number here for the amount of gasoline, I need to double check, it's not 20 pounds. Okay, so the activity challenge here is that you need to find and record every machine in your home as to how much energy it consumes, and then your goal is to design a way to reduce the energy consumption and eventually the carbon dioxide consumption by at least 10%. So you're going to work with your family members or other members of your household to complete this activity, because it will take some time to find every energy consuming device inside your home. You're going to translate that into a spreadsheet, a data that is entered into a spreadsheet, and do your analysis there. I will be able to provide you a template, or you can create your own. And you can also go ahead and compare what you find with your actual monthly electricity and gas bills. Okay, so with that, I'm going to wrap up this part 2 of the energy lecture. Please go through supporting slides, especially go through the NASA website on climate change, and make sure to complete any other activities outside of the design activities that you're going to do that are related to this lesson. Thank you.